All right. So I think everybody's in, so let's get started. Hi, everyone. Welcome to Orion's Belt's panel with the Lunar Architecture Research Group. For those who are new to Orion's Belt, we are a student-led organization dedicated to inspiring young space exploration and astronomy enthusiasts around the world. So I'm Ayan Naha. I'm a 16-year-old from California, and I'm a content specialist for Orion's Belt. So today we're hosting a panel with four researchers from Adelaide University in Australia who specialize in lunar architecture. So our four guests are Souktik Bhattacharjee, Monika Stankiewicz, Albert Rajkumar, and Meriem Allani. So to start off, we can have each of our guests introduce themselves, what their research is focused on, and then we'll start our discussion. So if any of you want to start.
Hi everyone, myself Souktik Bhattacharjee. I am an architect uh, and did my architecture studies back in India. From Jadavpur University, did my architecture bachelor's degree and then master's in urban design. Then I was very passionate about the space architecture. I did some experience in this whole industry. I had some researches going on back in my university, and now I am at the University of Adelaide in the Lunar Architecture Research Group. My research mostly focus on the intersection of space medicine and space architecture, which looks into human physiology as well as how they will react to the environment and how we can make their life a better place to live and also give them the proper instrument when they need when in the case of medical emergencies. So that's the broad area I'm looking into. I am also the founder of Laser Lab, which is my initiative to spread space architecture education. The best way to get to Laser Lab is to follow our Instagram page. And we also have a lovely website. You can check out our projects. And yeah, looking forward to the discussion.
Hi, everyone. My name is Albert. I'm here at the University of Adelaide doing my PhD. So my PhD rotates around how humans and robots we work together to build and design things on the moon. So we are here in Adelaide. What brought me here was I did my sort of architecture, so I have an architectural background. And for my master's, I did something called Master of Science in Space Architecture. So that was when I came into this realm of space and learned how to design things in space and how to design missions, how to keep the people happy, most important in this time when we're going to be going back to space, back to the moon for not just to visit for short periods of time, but for long periods of time. So that's a bit about me. Thank you.
Howdy, folks. My name's Monika. So I'm also, as you can see on the screen, a PhD researcher at the University of Adelaide. My PhD topic focuses on how to design easy-to-repair lunar regolith architecture, or as I like to call it, advanced space Jenga. Can you design a structure so that you can pull out a block and replace it without the rest of it falling down? In terms of my background, so I also have an architecture background, but the way I got into the space industry or into space architecture was actually by getting a job at a startup that was developing a plasma propulsion system and then just kind of going along from there. So I'm sure I'll be able to talk about it a bit more later, but I've been around for a little bit and I'll just pass it on to Meriem now.
Hi everyone, my name is Meriem. I'm originally from Tunisia. I'm an architect by background, as of all of you guys. I'm also doing my PhD in space architecture at the University of Adelaide. That means basically study how to design buildings for places like the moon and Mars in extreme environments. And basically, my research focuses on a very human question. Basically, what happens to people when they live in isolation for a long period of time, and how design make those environments not just survivable, but also livable. So that's that's basically about me, and yeah, we can discuss a bit more later.
Okay, that's oh, you want to say something?
Sorry about that. It was just like, thank you for those wonderful introductions. We are so happy to be hosting you guys on today's panel. With that said, we will begin our panel discussion right now. And so I would like to introduce our executive team who will be asking the following questions. That includes Iman Poonawalla, our Chief Operations Officer, Lovely Gebayehu, our Chief Content Officer, Minwen, our Chief Marketing Officer, Angelic Z and Shagun Srivastava, our Public Relations team, and Ayan Naha, Yuga Madalagi, and Adar Gupta, our Content Specialist team. And my name is Srinaja Chikapalli. I'm the founder and CEO of Orion Spelt. And without further ado, let's get started.
Okay, so I'm going to start off the discussion with a kind of basic question. So what exactly is space architecture, and how is it different from architecture here on Earth?
Oh, I can take this one if that's all right with you guys. So, space architecture, okay, it's defined as the theory and practice of designing and building inhabited environments in outer space. Okay, so what does that mean? Imagine you're building a house or a home outside on the moon or in space, right? You're building there. And so these are places which basically are very, very extreme and they want you dead. Right? On Earth, we worry about rain and temperature and earthquakes a little bit. But on the moon, we have to worry about there's no water, no air, there's a bunch of radiation trying to kill you, small micrometeorites striking all the time, right? So we designed habitats that keep you alive. Like you remember, those spacesuits that people wear. So you can imagine us trying to design spacesuits that keep you alive in space, but for bigger groups of people, right? So big houses which keep you alive, and most importantly, keep you happy. Yeah. So that's what space architecture is in a nutshell.
So, going off of that, what are the biggest challenges when creating designs for the moon or Mars?
So I think I might take this one. So some of the biggest challenges are literally just dealing with that difference in environment. We're not used to designing for things in microgravity or without the protective effects of our atmosphere. So the biggest challenge there is the environment, and also dealing with the logistics of designing for those environments where you can't readily access them all the time. So if every single time you had to go fix a broken component or go rescue someone, it was a 3 to 4 to week-long round trip, that inherently increases the complexity of what do you bring with you, and also how do you design your things so that they exist sustainably in the intended environment.
I'll take us to the third question, which is how do space architects make sure astronauts feel at home in such extreme environments?
Maybe you want to take this one?
Yes, I want to take this one. Basically, sometimes when you're like, I like to think it of us like during lockdowns and when you feel like a bit trapped. Astronauts actually live that for months and in tight spaces and with the same people, no fresh air and often no sunlight. So it's called like prolonged confinement. So it's not just a challenge for science, but also a challenge for mental health. So to deal with this, actually astronauts follow strict schedules. So they exercise daily, they have virtual calls with family and sometimes even they record video diaries. So I think from my perspective, like design really can help their habitats. So, for example, like thinking like quiet zones, having leisure areas, and probably like colorful interiors make a huge difference. So, just like home, how our cozy rooms make us feel like better, even like design in space helps people feel more grounded. I hope that answers your questions.
So how are emerging technologies like extended reality, AI, and robotics used when designing space architecture?
Right, yeah. So I work on this. This is my area of research here at the University of Adelaide. So what I do is I combine a couple of things. Virtual reality, that's sort of one bucket. The way humans and robots work together, that's another bucket. And the third bucket is sort of how do we build or design for the moon, specifically the moon, right? So these are three sort of concepts that I try to juggle together. And as for, I'll tell you a story. So when the humans and robots, we work together here on Earth, it's either we control them by sitting on a driver's seat and we drive around a big dump truck, let's say, right? So that's a human and a big robot working together. In other instances, there's a human sitting inside a crane and the human is operating the crane arm, right? So imagine, you remember those claw machines, right, in arcades? So you line it up perfectly, you press the button, and just when you think you have got it, it slips. It's frustrating, right? So frustrating. And so this clumsy control, imagine using this to build not something trivial, but something on the moon. That can mean difference between life and death. And so this robotics, they need to be very resilient to failure. So that means when something happens where it's not expected, you need to be able to recover from that failure. And so in my study, I'm using tools like virtual reality to see how we can help train the astronauts so that they perform better, they're less stressed about it, and they're able to perform the tasks better, right? So that's the training part of it, using virtual reality and AI to sort of simulate what's going to happen on the moon so that we can train our future astronauts better. That's my research. Also, another side of my research is how these same technologies like virtual reality, mixed reality, they can be used on the moon so that the astronauts, when they're actually over there, they can perform better. Like, so imagine you're an astronaut and you have this helmet, right? And imagine you have all this information like Jarvis giving information to Iron Man, or you playing a game where there's like on what's it? There's PUBG and what's the other big battle royale game where there's like um, the directions telling you that this way is home, you're facing that way, and your next target is there. So this is some examples. That's a very small example, by the way, of how emerging technologies like AI, robotics can be used for designing in space. But there are a lot of other people doing a lot of other work regarding other emerging technologies here.
That's really interesting. I wouldn't have thought that you could use that in space as well. So that's really cool. So our next question is going to be like, what kind of materials would be used for construction on the lunar Mars? And then a follow-up to that is like, how can lunar designs be made from repairable materials?
Okay, so this one fits really neatly into what I'm looking at. So in terms of the materials that are used or could be used for construction, what you'll notice is that at the moment with rovers and with what we're sending up, there's a lot of prefabricated elements that we're sending from Earth. So, but as we get more used to the lunar environment and we send more stuff up, that's where people are looking at using in situ materials or locally available materials on the moon to build whatever they would like to build. So this idea of what is a repairable material is actually a really interesting one, because you've got, for example, self-repairing concrete, which is a material that is being developed on Earth, but is that something that would work in space? So that's something that we're not necessarily sure about. But one of the things that I'm looking at isn't necessarily whether or not the material itself is self-repairing, but does the use of the material and the elements that you're using to, or that you're creating with that material, are those elements, building elements, are those architectures logistically repairable? So what that means is if you're using a locally available material, that would mean that you would have, if your component breaks or your block breaks, you can collect more of the material locally to create a replacement. Versus if you're creating something on the moon, but it uses wood from a forest or on Earth, then if that component breaks and you have to have this one specific type of wood, then you have to then communicate back to Earth that you need a replacement part or a replacement material. They then need to source the material, get it to your payload, which you then need to get into your rocket, which you then need to launch into space, which you then need to perform your orbital maneuvers, which you then need to get to the moon, which you then need to land on the moon, then get out of the rocket, then have your astronauts or whoever pull it out of the rocket and then use it. Versus, that whole process, if you're using lunar regolith to design your protective architectures, instead of all of that, you send out a rover or a robot or collect a bit more of the material, perhaps process it through sintering or casting or whatever manufacturing technique you're using there, and then you have your component on the spot ready to go back into your structure or into whatever you're using. So this idea of what is a repairable material, it's connected to the broader context of where does that material exist and where do you need it to exist and where do you need to use it. So the world of materials is a very large and fascinating one, and I think I will pause there because otherwise I will just kind of keep going. But if you have more questions, I'm more than happy to answer them.
Okay, so for the next question, we were wondering what are some opportunities for high schoolers and young individuals when it comes to space architecture?
Yeah, okay, I will take this. So there are a lot of opportunities where you can contribute to the space architecture. So right now, there are graduate programs like SIXA at the University of Houston, where you can join for the master's degree as the Rajkumar did. And there are also some courses in international space universities. And right now, in the University of Adelaide, we have the Lunar Architecture Research Group, where we are doing PhD. So these are some of the academic sites, but also you can contribute to the space architecture community through the conferences, some of the active conferences like ICES conferences, and there are other conferences that goes on. And also the International Astronautical Congress will also have a panel for the space architecture. So yeah, there are a lot of areas where you can contribute your researches to, you can build your projects, and yeah, like it's a growing market, and you can even find the guidelines from the NASA documents where the space architecture is mentioned and the works are there. Yeah, those are some of the areas I think you can really contribute to.
I can add a little bit to what you're saying, Shaktik. From my side, I would say start with what excites you. So drawing, building, coding, psychology, biology, everything is in the realm of space, right? So you can study architecture, engineering, space science, art, and so there's no single path. You can, right now, where you guys are in high school, try to explore everything. There are a lot of free courses, free design competitions. There's one running that we are running right now called the Australian Architecture Space, the Australian Space Architecture Challenge. So there are many, many design competitions, free courses. Try to get some internships. Try to see where this local space companies are around you, and there are lots popping up nowadays, right? So we need all kinds of thinkers. Try to explore, and yeah, space is a very wide field, so it's very welcoming.
That's just incredible. I mean, there's so many opportunities out there for youth, so that's wonderful. Thank you. And kind of looking into the future, what lessons can be learned from lunar architecture that could help us build more resilient or eco-friendly structures on Earth?
Who wants to take this one?
Well, I think Miriam's keen.
I guess Monika
Well, I
is
can
more.
also take it. No, that's right. Okay, so one of the things to keep in mind when designing for that space environment is that in order for your designs to succeed in that space environment, they kind of need it, well, not kind of, they need to be ultra sustainable. They need to be designed so that they're resilient, so that they can recover from failures, and so that the astronauts there or the inhabitants there can go out and fix them. So what that actually means is that translating those lessons back down to Earth is actually an incredible opportunity to create the next age of architecture on Earth, or the next age of sustainable architecture. So one example that relates a bit to the health side of things is if you're designing your interiors for your spacecraft or for your lunar habitats so that they're injury friendly, so that your astronauts can exist there for a bit longer, even if they sprain like a wrist, for example, or if the microgravity impacts their eyes and they're a bit more short-sighted. If you design your architecture so that they can accommodate those changes in physiology or those injuries, then what that means is you can take those same design lessons and approaches and then apply them to, for example, retirement villages where people might be losing some of their eyesight. Or if you use them in everyday homes, it means that if you fall off a bike and sprain your wrist, you can still enter into your bedroom or bathroom or whatever, or use the kitchen. So that's one example of creating interiors that are more friendly for people, that encourage and foster that independence. But another example would be if you were to create something that's easy to repair, or do you create something that is created with locally sourced materials, then all of that embodied energy that is then taken up by taking materials from the other side of the world or from far off places could be saved. You can create more eco-friendly structures with using locally sourced materials on Earth as well, because then you're using less energy to create the structure in the first place, and then you need less energy to maintain that structure as it continues on. Another last example, I swear, would be if you create homes that are, or buildings that are highly efficient with heating and cooling, which is what they need to be in space, then what that also means is that you're using less energy to heat and cool those homes on Earth. And you actually improve people's quality of life because then they don't have to worry so much about paying those bills. So a lot of the lessons learned or design lessons learned, so for example, if you look at the space blanket, or if you look at the food safety standards that came out of going into space, a lot of those lessons directly translate into tangible benefits for people on Earth. And so that is something that I think is really exciting. And there are a ton more lessons than what I've just talked about there.
Wonderful, and that brings us to our Q&A session. These are questions that were gathered from our audience beforehand and will now be answered. And if we do have time, we may even open it up to a few impromptu questions if the panel is all right with that. But let's start off with this.
Yeah, so I found this question really interesting. It kind of brings together two different fields of sciences. So how can you use space architecture and technology to advance health?
Okay, so this questions quietly aligns with my research. So if you imagine that there is an architect in one hand, there is a medicine in one hand, both have pretty different job. One is saving the lives, is another is making the people's life better place. So yeah, no place for injury or making your life more comfortable. So and how these two places talk to each other is through mostly in the hospitals or in the corrective facilities. So these are the areas where like architecture works with healthcare people like doctors. So if you look into the history, you can find that there are a lot of doctors who have contributed largely to architecture, and there are a lot of architects who have contributed to develop the healthcare facility. So in the earlier, like in the modern times, how when the things were being developed, so the main terms were like hygiene and then SFC. So these are the areas where doctors and architects work hand on hand to develop our modern day hospitals. So you can quietly understand that how architecture and healthcare have worked together so far. But right now, when we look into the space architectural context, so the main questions that architects address is how to design the healthcare facilities for the astronauts and how we can make their life a bit safer, and how can that space be more useful to the people in terms of their changing physiology with the time on the moon. So if you imagine an astronaut going to the moon, so there are a lot of physiological changes that happens, like your eyesight become blurry, your bone density reduces, and then muscle density also reduces with time. Your upper body gets filled up with fluid. The fluid shift happens in space. So all these contribute to a lot of health issues, and it can cause us a lot of accidents. So to combat these accidents, we need facilities, and where the architects come into play to actually improve these areas. So that's where some way the space architecture is contributing to development of the healthcare facilities on moon. But these contribution also have large impact on the earth, because the same technology can be used in the extreme environments and also the remote areas like the outback of Australia or in the deserts area. So and there is also a large scope where we are looking into the remote diagnosis concept. So when COVID happened, you must remember that you were in the home and then you were calling doctors to treat you through video calls, and there are a lot of other technologies that evolved in this time. You understood that how these technology remote diagnosis actually work. So remote diagnosis, telemonitoring, telesurgery, so these are some of the areas which are emerging with the improvement of communication technology and artificial intelligence, and all these merge together towards development of the better space tech era. And yeah, that's how the space architecture is merging with the health sciences.
So that's a lot of good things, but I just wanted to add something to that because I just hearing Shoktik talk about all these things reminded me of something, which was when I was back in my master's, I did a project, and let me try to explain, give you a brief idea of what this project was. So in movies, you see all those big rotating space stations, right? In movies, in science fiction. Why do they rotate? Anybody can, do you want to take a guess? Why are they rotating?
I think because the centrifugal force is supposed to mimic Earth gravity.
Right, awesome, exactly. So we know a lot about what Earth gravity does to human beings, right? Because we've been on Earth for what, millions, hundreds of thousands of years. We know what zero gravity or microgravity does to the human body and mind for a long period of time. How? How do we know that? Does anybody want to take a guess? It's on
Yes.
the yeah, Achilles, go ahead.
By sending people to the International Space Station and seeing the effects of it.
Great, awesome. Yeah, so we've had people live for more than a year, right, on the International Space Station. Exactly. So we know a lot about what happens there, but do we really know what happens when we will send humans to the moon, for example? So on the moon, it's a very famous idea, right? On the moon, the gravity is reduced. So if you weigh 60 kilos here on Earth, how much you weigh on the moon? You weigh 10 kilos, right? 1/6 gravity. Isn't that crazy? So when we put people on the moon for a year, 2 years, 5 years, we don't know what's going to happen. So one of my projects was I had built or I had conceptualized this thing where we would launch like a small spacecraft. It would connect to the International Space Station from time to time, but it could also separate. It would separate and it would spin up, and playing with the rate of spin and how much uh, the the wires would be let out. You can control what gravity that you are simulating, right? So this is another example of in space architecture, what kind of projects people do to sort of advance the health sciences. So if you're studying how the lunar gravity or Martian gravity, we're going to Mars soon also, how these sort of weird gravities affect human health, both physical and mental, that is something that we can study too.
Okay, thanks for that answer. I think I want to talk about the next question. It says, how do you recommend students to search for and find opportunities in this niche competitive field? I think Albert talked about it a little bit, right? I also might want to add on to this question, where would be a good place to start for high school students as well, right? Because it's probably also a vast field as well.
Yeah, I'm just gonna really quickly say that there's a website called spacearchitect.org. That is one of the things. I'll just pop it down in the chat. So spacearchitect.org. That is something that you guys can look at. And I believe there's a lot more information out there. I'll let Monika, Souktik, or Miriam talk about it.
Yeah, I think what's important where to start is to find your area where you are really interested in, which area you are very passionate about, which area you want to really explore, and then look into the space documents that are released all over the year, like the yearbook and the one of the most important document is like Moon to Mars mission directed by the NASA. They all give out the research gaps that are there, the technological gaps that are there in the field, and where you can really contribute to. And that's something very good starting point. You can also look into the opportunities by the universities and the competitions. So yeah, these are the areas you can really learn with. There are a lot of learning opportunities out there. Like what I am doing myself in the laser lab is doing the contents which is about educating about space architecture and also broadly about space technology, where I try to delve into the problem solutions, what are the technologies that are there you can use. So yeah, these are some of the areas you can look into. I will also
So
pop the link of Laser Lab in the chat.
I'm just going to add on to what Souktik and Albert talked about and point out the fact that what you're doing right now, coming to this panel, is one of the ways that you can do exactly that and fulfill that question. Another way you can do that is by joining organizations like Orion's Belt and furthering their goals there, because in order to find opportunities in a niche competitive field, you need to get involved in the niche competitive field in some way. And even if you're not at a point where you can walk up to like a company or or if you don't feel like you're at a point where you can walk up to a company and go, hey, hire me, I'm great. You can still get involved in outreach programs or go to conferences where there are a lot of student pricing. So, for example, the International Astronautical Congress, that's one of the ones where it covers just about everything to do with space. And so you can even just flick through the technical documents there or the programs and just look at, well, what would spark your interest, what wouldn't, go to those sessions. You can also, I know that in America, in Texas, next year, there is the ACSC Earth and Space Conference, which I can chuck a link to in the chat, unless someone else gets to it first. And that's something where, if you can afford it, even just going there, you're going to be presented with papers from the most recent developments in architecture and construction in the space industry. Another thing that you can also do is, okay, so a lot of you are in that high school bracket. You could also get involved in outreach programs for primary school kids, because even though you might not necessarily feel like you fully worked out what you're interested in and what you're not interested in yet, you can still talk to younger kids and help grow them. And in teaching them and mentoring them, you'll actually learn a lot about yourself in the process as well. So being really actively involved in any way that you can is great. And the last thing that I would add on to that, so finding your passion is great. And it is solid advice. The other piece of advice that I give people is also find out what you're not interested in. So, because sometimes if you're like, I'm interested in kind of everything and I'm not really sure, well, go out, try different things. Even if you try something for a few months and you go, you know what, I actually really hate doing this, or then that narrows down what you can look for later on. So there are a few different approaches there, but getting involved in initiatives like Orion's Belt absolutely will get you closer and closer. Otherwise, stuff like joining the AIAA, I think they're, and from memory, an American organization, they're quite actively involved. And a lot of the students that I've seen that have been actively involved in those sorts of organizations or volunteer organizations, they tend to find their place because they build those connections and they get to have those conversations with people where they can go, hey, you've got a pretty cool job. How did you get there? Like, how do I follow in your path? Or, hey, you've got a pretty cool job. What do you actually do? Because sometimes our impression of what someone does is actually quite different to what they actually do. And being in a position where you can talk to those people and ask those questions to take advantage of their life experience, that is insanely valuable. And that's something which I didn't necessarily do when I was a high schooler, because I thought engineering was just doing math all day. And then I went, and now most of my friends are engineers and they actually like get to build really cool things. And I'm like, oh, okay, if I had maybe a better idea of what engineering was, maybe I would have gone down that path. But I have no regrets about the path that I have taken, because I was interested in everything, and architecture has a bit of everything.
Yeah, so just adding a little bit to that, sorry about that. Monika was saying something about connections, right? Making connections. I think that is a very good opportunity for you as a high school student to sort of get one foot in the door, right? So networking. How many of you are on LinkedIn? You guys are on LinkedIn? If you're not, yeah, I can see some of you are. If you're not, consider getting a LinkedIn profile, because it's like, yeah, a lot of the people that you would possibly want to talk to are on LinkedIn, but it's not important that you be on LinkedIn. The main thing is you reach out to them, you talk to people, you expand your horizons, like Monika was saying. I think that's the best.
Yeah, I was just gonna add all of what you said is amazing, is great advices, and what I would add is start by being curious, like, and after that, then learn how to connect different fields. For example, like space architecture is not just about rockets or buildings. It brings like together architecture, design, engineering, environmental psychology, like sustainability, and even like arts and storytelling. So that means you love design, learn how to create spaces that support human life. Love space, dive into astronomy, physics, and planetary sciences. Love helping people, maybe explore psychology and how environments affect the brain. So the most important thing here is to build a foundation in critical thinking, especially as high school students, and creativity, and learn how to collaborate. So my advice is don't be afraid to explore. Even like small school projects, like my colleagues already suggested to do. Like imagining, for example, life on Mars, or designing a tiny house, like can be a very first step, and help you really know what you want to do like in the future.
Yeah, wow, that was great. That was like a lot of different responses. So this next question, Albert, I know you kind of talked a little bit about this, but the question is, how broad is the topic of space architecture, and is it limited to just land-based structures, or structures orbiting celestial objects as well?
No, it definitely is not limited to just land-based structures or orbiting, although it can be orbiting. So, yeah, orbiting, let's classify it as one avenue, right? Orbiting around Earth, orbiting around Moon. One friend of mine, long time ago, he did a project of how to explore one of the moons of Jupiter, right? So it can be as crazy as that. So some person did something on here on the moon, on Earth, where there are these things called analog missions, right? So what are analog missions? Analog missions are when you want to study about space, simulate what is going to happen to space, but you don't have the time and money to go to space. What do? You make something in the middle of a desert, right? You make something 60 feet underwater, right? So these are called analog missions, where you are trying to understand what space architecture can be like. So these can also be regarded as part of space architecture. A lot of people do analog missions. A lot of people do lunar architecture, like us. We are specialized for lunar architecture. There are people who are studying Martian architecture. There are people, like you've said, who are doing orbital structures. And there are people who like remember that series called Expanse. If you haven't watched it, I recommend that. That's a good series to watch, where there's people living in the future. There's people living in the asteroid belt, right? They're miners. They live in the asteroid belt, and because they've lived there for so long, their bodies start to get all warped and like long and stuff. And so that's very interesting. So it's a very broad topic. There's a lot to it. Does anybody want to add something to this? Guess not.
Well, I
That's
think
cool.
I think you
Oh.
covered it pretty well. Like, in terms of space architecture, the only way I could really go broader than that is that space architecture exists within the realm of extreme architecture because it's designing for extreme environments. But that's where, you have those analogs so that you can simulate parts of that. But you're also within the realm of extreme architecture, you're looking at designing Antarctic bases, for example, or deep sea bases. Like, these are also extreme environments, and I don't think we've actually explored all of the Earth's oceans yet. So there is a lot, like, we can go to a lot of interesting places already on Earth, and we need people who can design for those intense pressures, environments, sort of thing. So as an example, how would you design a base for the top of a volcano? Could you design something that actually survives an eruption? That's another extreme environment. But then I think a lot of the fun and that broadness of space architecture is designing for those environments where the rules are completely different. So some of the posters that we actually have up at our lab are some of the NASA tourism posters, where they actually have if you have a look at the posters, concepts for different habitats that would, or different structures or architecture that would play well with the like local environments there. And it actually starts getting a bit fantastical, and like kind of fantastical in a semi-realistic sense, because they wouldn't have pulled those concepts out of nowhere. But I think in terms of how broad does the topic of space architecture reach, the only real limit, and this sounds incredibly cheesy, is your imagination. Because architecture fundamentally dictates, or our architecture fundamentally creates the sea or the environment that we all move within. You are surrounded by architecture. Architecture impacts your everyday life and is one of the primary indicators of how healthy you're going to have a life. Because if you spend the rest of your days in a small isolated box with no outside contact, you're not going to stay sane for very long. But if you're in a place that is built for community and connection, despite an increasingly extreme climate, then you're going to do a lot better. But yeah, so that's my 2 cents to add on to what Albert said.
Okay, so I have the next question. It says, in space habitat design, how do engineers approach material selection, especially when considering incidental resources like regolith? If I'm not mistaken, regolith is like the layer of like heterogeneous layer across like planets and moons, right? Like that exterior, right? So I guess that's what most of the time architects have to consider. And then can civil engineers contribute to this development? And then maybe you can even like add on like what are some materials that you guys are considering now that's like up in the forefront and things that are really interesting currently?
So I think I'll take this one. So in terms of material selection, in terms of like particularly from that engineering approach, we actually have quite a few materials engineers or material scientists at the University of Adelaide working with regolith simulants or regolith materials. One of the things that's a bit interesting about that is they're also looking at what composite materials that they can use or create using regolith. So one example is regolith mixed with, I don't want to say acetyl. I can't remember the name of the material, but
People are doing
resin.
resin.
There we go. Yeah, resin. That's the one. So regolith combined with resin, and then looking at how does that change the material properties of regolith. One of the really interesting things that I learnt when I went to the ACSE Earth and Space Conference last time, which is biannual, was that a lot of the geotechnical, a fair amount of the geotechnical knowledge that people are working with, or the knowledge with regolith, are based around assumptions or based around working with simulants. So at the moment, civil engineers, geotechnical people, material scientists are building up this body of research, but until they can get more samples back from the moon to validate their research, or they can go to the moon and test out some of their materials assumptions or that they've made, they're kind of in this black area or gray area where they're like, well, okay, we're fairly certain this stuff is going to work, but until we go up there and actually get to play with the material itself, it's hard to be 110% certain. So in terms of material selection, well, I suppose going back to the broader question there, they're looking at how usable is the material, what is its compression strength, its tensile strength, what forces can it withstand, how easily can you manufacture with it. So for example, when you're considering 3D printing with regolith on the moon, one of the things that people look for is how consistent is your particle size? Because if you've got little bits of regolith and some of them are bigger, some of them are smaller, the bigger ones could clog up your nozzle, and then you have a misprint halfway through trying to create like a space habitat, and you don't want that. Another issue that people are tackling with regolith is the fact that it's razor sharp. So if you think of sand, and then imagine that that sand is actually icing sugar, and now imagine that that icing sugar is actually broken needles, like thousands of broken needle tips or pin tips or whatever, because it hasn't gone through that process of erosion, and it hasn't had those sharp bits knocked off. Now you're dealing with a material that simultaneously is great for building with because it's locally available, and we have a lot of experience building with earth-based structures on Earth. But it's also the single most dangerous material to your manufacturing equipment and to your people up there. So it's kind of like this love-hate relationship with the material, which is why people are trying to look at how to make it more usable and what building construction technologies or what building construction technologies are enabled with using that material. So it's interesting. Civil engineers absolutely can contribute to this development because at the end of the day, it's all well and good if you've got a material, composite or just purely locally derived. But what structures can you actually build with those? Can they withstand those micrometeorite impacts? Do they actually protect you from the radiation? Do they actually give you a thermal environment that is comfortable for the people inside? Those are all questions that civil engineers can help to answer with some really creative engineering. It's one of those really interesting things. I remember seeing a paper where they actually found like silica as well on the moon, or like these little glass beads. So there was this idea of you could create, I think the colors were orange, green, and maybe like a whitish sort of see-through. You could create stained glass lunar windows if you wanted. And then that starts creating this uniquely lunar piece of art or decorative element that would be completely unique to the surface there. So those are some of the considerations, and those are some of the ways that you can contribute.
Okay, so one of our members said that she is actually finding graduate programs tailored towards space architecture and engineering, and wanted to know what paths were taken to get to where you are now.
I feel like I'll let one of the others jump in first for this one so that you get a break from my voice for a bit.
I think like all of us studied architecture here, so all of us we have architecture background, but you can definitely choose any path because space is like a multidisciplinary. So basically anything like engineering, arts, even literature, like basically anything. So you can, if anyone wants to add on that.
Yeah, I will shortly add to that. So, how my journey started is when I joined architectural studies in my bachelor's degree in my second year or the first year. I got a competition called the Moonception or the Marsception by Vol Zero. So yeah, I participated in that competition. It was about building a habitat on Mars. So yeah, that is the first time I came to know about space architecture. And then I researched for a while, and then I found that there is a lot of researches that is going on all over the world. And that's when the space architecture really stuck with me. And then throughout my bachelor's program, I started looking into different aspects of space architecture. And I remember after that, in around my third year, fourth year, I did some research journals like on the internet, like the blogging on the history of space architecture, about finding that how the space architecture have evolved over time. And then I remember I joined some industry spaces as well on the space architecture, where my most focus was on deployable structures on space architecture, like on the lunar surface mostly. So yeah, like we focused on origami shaped structures. And that's when I realized that, okay, I need to study more about it. And then I did my dissertation and pre-thesis on this topic called the class 2 lunar habitats, where we utilized the origami patterns to develop the habitats, deployable habitats on the moon. So what happens is that you take the whole habitat in a collapsed format and then spread it in the moon so that you get a larger habitable volume. That's the whole idea behind it. And my study was around that in my bachelor's level. And then in around the masters, I did some researches on how the lunar urbanism would look like. What it meant is that when you goes to moon and there are many people, like hundreds of people, then how would the common people, like the common public space would look like? So these are some of the areas I looked into, and then I also looked into some habitable areas on the moon, how we can utilize the GIS and remote sensing to utilize to see what's the most habitable area, what's the most efficient area on the moon to build the habitat on. And then yeah, like I joined the PhD program, which is a bit different, but I was working on this for a while I was looking into how robotic surgery can be performed on moon, what are the protocols can be found, what is the best spatial configurations, and those are the things which I guess you can find in my ResearchGate platform about the research that what I did. And yeah, those are the and that's how I led towards the path for the PhD in space architecture, looking into the medical science as well with architecture. Yeah.
Well, wow, that was incredible to say the least, and that was such a good panel discussion. So thank you so much. I did put a message out in the chat saying that if you guys have any questions, feel free to put them in there. However, it looks like we are kind of on time, and there were a lot of questions. So just asking the panelists, would you be all right to maybe answer some of these questions later on, and we can get them to our members afterward?
Absolutely.
Just email it out to us,
Absolutely.
Sunny.
Yeah.
Yeah.
Okay, awesome. Well, that brings us to the end of our panel discussion. First of all, I'd like to say thank you so much to everyone who joined and for joining the session, but also supporting our mission of making space accessible to everyone. I'd also like to thank the Lunar Architecture Research Group, Mr. Bhattacharjee, Mr. Rajkumar, Ms. Stankiewicz, and Ms. Allani for taking the time to share their incredible insights with our attendees. We are truly honored. Human space exploration is undoubtedly the next big leap in space exploration as well as for humankind. And so getting a glimpse at some of the systems that will be taking us there very soon is just incredible. I'm personally excited. I don't know about you guys, but we'll be using VR, AI, repairable materials, and it'll be just like our next home. It's perfect. So I can't wait personally because the future of space is unfolding right in front of our eyes, and it depends on everyone in this session. So please stay connected, keep learning, and never stop reaching for the stars. Feel free to stay connected with the Orion's Belt community through our social media and blog, as well as the amazing team behind the scenes at our website. Thank you so much, and we hope to see you ahead on the journey. Thank you, everyone.
Thank you so much.
Hey, everybody.